So today we'll be learning magic square. What is magic square? Magic square is basically a square matrix of odd order. For example, it can be of order 3 cross 3, 5 cross 5, 7 cross 7, 9 cross 9, etc. Now, what is magical about this square? If you take the horizontal sum of every element, it should be equal to the vertical sum of every element, and that should be equal to the diagonal sum of every element. Remember, this diagonal sum is equal in both cases. For example, when you take the sum from left to right as well as from right to left. Now let us see an example. For example, this is a magic square. Now if you take the sum, horizontal sum, it will be 6 plus 1 plus 8, 15, 7 plus 5 plus 3 equals 15, 2 plus 9 plus 4 equals 15. Similarly, if you take the vertical sum, like 6 plus 7 plus 2, it will be 15, 1 plus 5 plus 9, 15, 8 plus 3 plus 4, it will also be equal to 15. Now you take this diagonal from left to right, that is 6 plus 5 plus 4, it is equal to 15, and again you take this diagonal, 8 plus 5 plus 2, that is the diagonal from right to left. So in all these cases the sum is equal to 15. Now let us see how can we form a magic square. So let us check out the algorithm. Now this is the magic square formation algorithm, but before learning the algorithm, it would be better if we can trace the algorithm and at the same time we learn the algorithm. Okay. Now let us try to form a magic square according to this algorithm. Now, what is shown in the first step? In the first step, it is told that write first element in first row mid column. What is the first row? This is the first row, and the mid element and the mid column is this one. So you have to write over here. So I'm writing the first element 1. Okay. Now we move to step 2. Step 2 tells that move diagonally upward in northwest direction. For example, in this way, that is in this way. Right? Now see, when you traverse in this direction, that is diagonally upward, you come to this place. Now this is basically, here no cell exists, there is no room, and if you see carefully, this place is outside the row. There is no row over here, but if you check, there is definitely a column. This column does exist over here, this column, the first column. Now see what the steps is telling. In step 3 we have different cases. Now the first case tells you that if the cell is empty, then do something. Now the cell is not empty because there is no cell actually. If the cell is filled, do something. No, there is no existence of any cell over here. If you fall outside row, yes, we are definitely falling outside row because here no row exists. So condition C tells you if you fall outside row, write next element to last row. So we have to move to last row to write the next element. So this is case C, and we move to the last row here. This is the last row, and I write the element, that is 2. Okay, now see, we have to move. Now once this condition is satisfied, if you fall outside row, write next element to last row, this condition is satisfied. So we should come out of this step 3 and again iterate from step 2. That is, we have to again do the same thing, that is moving diagonally upward. So we move diagonally upward in this direction. Now see carefully, when I move to this direction, we are basically outside the column, right? Because no column exists over here, but there is definitely a row. This row is the second row. So this condition D, if you fall outside column, this condition is satisfied. So if you fall outside column, write next element to last column. What is the last column? This one. So we have to write the next element over here. So the last element is being written. Now what should we do next? We again go to step 2 and move diagonally upward. So we are going in this direction. But this room is already filled. Now see, this condition is satisfied. Sorry, the second condition, the B condition is satisfied. If the cell is filled, yes, the cell is filled, write next element just below the previous cell. This is the previous cell, so you have to write just below this here. So I'm writing this 4. Now again move diagonally upward. So I'm moving over here. When you move to this cell is basically empty. So condition A is satisfied. This is condition A. Condition A is satisfied. So I'm writing the next element, that is 5. Again we have to move diagonally upward in this direction. Again this room is empty. So condition A is again satisfied. This is condition A. So I'm writing 6. Okay. Again we are moving diagonally upward. Now see, when you move to this location, this particular location, you are basically falling out of the matrix because there is no row is existing and there is no column, right? So you are falling outside the matrix, that is falling outside the row as well as falling outside the column. Now see, condition D is satisfied? No. If you fall outside column, no, because we are falling outside column as well as outside row, that is we are falling outside matrix. If you fall outside matrix, then write next element just below the previous cell. Which one is the previous cell? This one, 6. So you have to write just below 6. So here I am writing 7. The next thing is, again we are moving diagonally upward. So we are moving diagonally upward and we reach this location. Now see, this is basically we are falling outside column but not outside row. This is the first row. Okay, so we are falling outside column. So if you fall outside column, write next element to last column, that is condition D is satisfied, right? This is the last column, this is the last column, so you follow the same row and write next element over here. Next thing is you have to move again from right to left, that is in northwest direction, right? Now if you move here, what happens? You are falling outside row, but you are within the second column. So if you are falling outside row, that is condition C, then write next element to last row, means this is the last row, this one is the last row, so write the next element here. Again you come to step 4. Iterate from step 2 until the matrix is filled entirely. Now this matrix is entirely filled, so you need not to write any more element. So this is the magic square. This is the formation of magic square. Now let us do the same thing in a 5x5 matrix. This is a 5x5 matrix. So I am writing the first element in the first row mid column, that is 1. Moving diagonally upward, I am coming here. We are falling outside row, so go to the next last row, that is this one. Again move diagonally upward, the room is empty, so write 3. Again move diagonally upward, you come here and you are basically falling outside of column, so you go to the last column, this is 4. Next move diagonally upward, write 5. Move diagonally upward, this room is already filled, so go to the previous cell, 5 is the previous cell, write just below it 6. Okay, next again move diagonally upward, that is 7, diagonally upward 8, diagonally upward. Here we are now outside what? Outside row, so go to the last row, that is 9. Again diagonally upward here, but we are falling outside column, so go to the last column, write 10. This room, as you move diagonally upward, you encounter 6, so the room is already filled. Go to the previous room and just below this previous room, so filled 11. Move diagonally upward, 12 diagonally upward, 13 diagonally upward, 14 diagonally upward, 15 again diagonally upward, and now you are basically here, so you are falling outside row as well as outside matrix, outside column. That means you are basically outside matrix, right? So you come to the previous cell and just go below that cell, that is 16. Again you move diagonally upward here. Here you are falling outside column, so go to the last column, that is 17. Again move diagonally upward. So as you move diagonally upward, you come over here, right? Now here you are outside row, so go to the last row. Last row is this one, so write 18. Move diagonally upward, 19, diagonally upward, 20, diagonally upward, 16. The room is already filled, so come to the previous cell, go just below this, write 21. Again from 21 go diagonally upward, that is 22. Again diagonally upward, you come over here and you're falling outside column. So go to the last column, right? 23. Again go diagonally upward, 24. Diagonally upward, you come over here. Now this is outside row, so go to the last row, that is 25. Now if you take the sum row wise as well as column wise, that is horizontal, vertical or diagonal, in both ways, you will get sum equals 65. Thanks for watching.